All right, 2010, number 2, and we have a TI on this one. So we're at a zoo, and we've got entries, and we have hours, and we have this table to work off of. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at 6 and show the computations. Again, the rate is a derivative. The derivative is a slope. I can't find a derivative because I only have a table to work off of. Therefore, I'm going to use a slope of a secant to approximate. This should be a little familiar by now because I think this is the third free response question where we've had to do this. So you should see some repetition here. Okay, so I'm approximating the rate at 6. So I'm going to use 5 and 7 as my 2 points. Approximate. Make sure you realize this is 400 entries per hour, okay, because everything is in hundreds of entries. Part B, use a trapezoidal sum with 4 subintervals given by the table to approximate this value. And then we have to explain what that integral means. So when I look at this, this is what they're asking me to find and approximate with trapezoids, and then I have to explain it. So I kind of plotted out the points. I'm a visual, you know that. So I have this triangle here. I found the area of that. And then I have the area of each trapezoid. If you'll recall, the area of a trapezoid, 1/2 height times base plus base. And again, the bases are coming from your y coordinates. That's where you're getting those values. So I find the areas of my trapezoids and my triangle. I add them up, and then I have to multiply by 1/8 to get my final answer. And then I have to explain what that means. And because you have that 1/8 out in front, that means it's the average. So this is the average number of 100 entries in the box between noon and 8. That comes from my limits. Part C, volunteers begin to process the entries. And this is where they give us P of T, which is hundreds of entries per hour. So this is a rate. How many entries had not yet been processed by midnight? Well, let's figure out how many were processed. So I need to add up all the entries that were processed. That means I want to integrate P of T. I'm adding up all the entries that were processed from 8 to 12, 8 to midnight. And when I integrate this, I put the formula on my calculator. Just do it on the calculator since you have it. Integrate from 8 to 12, you get 16. Now you're not done there. They're asking me how many had not yet been processed. So if I look at this, at 8 o'clock, there's 2,300 entries that were in the box. And how many were processed from 8 to 12? 1,600. Subtract them, that means that 700 entries had not yet been processed. So that's the answer they're going after there. Okay? Part D. According to the model from Part C, at what time were entries being processed most quickly? So this is the rate that they're being processed. I want to know, when is that happening the fastest? So when does that P of T, when do you have a max there? And justify your answer. So here we go. You're processed the most quickly, that's your max, when P prime is 0 or D and E and you have a sign change plus to minus. I find the derivative and I want to know when it's 0 or D and E. So I put this on my calculator. When does it equal 0? At your x-intercepts, and those are the points there. So then I have my P prime number line. They're telling us to use information from Part C. That means I have a closed interval from 8 to 12. So I'm looking at this, and my graph is increasing and decreasing and increasing. Those are my x-intercepts that I found. Potential maximums, 9.184 or 12, which is my close, that's my endpoint. So I need to find the rate at which you were processing at these 2 times to figure out which one is actually going faster. So I need P of 9.184, and I get that answer. And I need P of 12, and I get 8. Therefore, they're being processed most quickly when T equals 12. This is one of the few situations or a few examples we've seen where the endpoint is actually your answer. So don't forget, when you have a closed interval, those endpoints can be absolute max or mins. And in this case, that is your answer.